How did you get the 1/3?
3/9.
Oh. Okay.
You can keep it as 3/9, but still you'll simplify it later. Same thing.
Yeah, no, I understand.
No worries. Okay, back to the list. Are we okay with the binomial theorem?
Can you go over that, please?
Yes. Do you want to make one up, or I will?
You can go ahead and do it.
Okay, I will. Here it is. Let's say 3x² minus 2y. Give me a power. Not too big because it's beyond the scope of what we're trying to do. We're just trying to understand the rule. I mean, you can say 11 and it will take me an hour. I'm kidding, but it will take a while. Let's say
2/3.
Okay, that's fine. We can look at the fourth. Power 4, 5 terms. You can find the coefficients very easily for power 4. 1, 1, 1, 1, 2, 1. Remember, this is degree power 2. 3 terms. 1, 3, 3, 1. You know how I'm getting these numbers. These are always ones. These are always ones. This is 1 plus 1. This is 1 plus 2. This is 2 plus 1. 1 again, 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1 again. So this is degree 3, and this is degree 4 because it has 5 terms. These are the coefficients in front of each term, but not the final coefficients. So I would write 3x² minus 2y to the 4th. Because there is a minus here, the signs will alternate. Plus, minus, plus, minus, plus. If there is no minus, everything is plus. But there is a negative. Plus, minus, plus, minus, plus. Signs will alternate. So the first one is 3x² with 1 in front, but power 4. Then minus 4. 3x² decreases its power to 3, but now the other term pops in to power 1. I'm here, plus 6. The first term, which is 3x², went from 4 to 3. Now it has power 2. The second term, which is 2y, went from power 0 to power 1 to power 2. Negative 4. The first term started with power 4, went to 3, went to 2, now it's power 1. The second term went from power 0 to power 1 to power 2, then this must be power 3. Final term, positive 1. There is no more term 1. It had power 4, 3, 2, 1, now it's at 0. The only term now is 2y. And finally, it increases its power to the maximum. It was 0 here, was power 1, was power 2, was power 3. This must be power 4. It's not done, because I have to raise 3 to the 4th power and x² to the 4th power. Then I have to simplify this, multiply by 2y, and multiply by negative 4. So each and every term has to be cleaned up. But I obtained the 5 terms that I need. 1, 2, 3, 4, 5. And now I clean it up. And that's final. This is really like a little puzzle. I did put a problem like this, but since I do not consider it utmost, I think I put it as an extra credit. It will take you 3 minutes, 5 minutes to do it, and I recommend please do it. Okay. I do not think that this is my you know, a major, it's a minor situation. It's not super important, but it will give you 10 points very easily. So 3 to the 4th is 81. X squared to the 4th is x to the 8th. This is the first term and it's done. Now I have 4 times 8, but times 3 to the 3rd power, which is 27. So 27 times 8, I got 216 minus 216, x to the 6th, and times y. This is the second term and it's done. Plus, I have 3 squared, which is 9, times 6, but times 4. I have again 216, x to the 4th, y squared, minus. Done, this is term 3, done, carved in stone, minus. I have 12, 4 times 3, but 2 to the 3rd is 8. So I have 96, x squared, and y to the 3rd. This is the 4th term, carved in stone. Finally, 2 to the 4th, 16, y to the 4th, and this is done. Can you simply multiply this 4 times? Yes. Will you get the same answer? Of course. But look at the numbers. It will be very easy to make a mistake. So the binomial theorem is very useful. What is the most useful thing is for you to please remember, when we have a binomial to the 2nd power, we get 3 terms. If we have a binomial raised to the 3rd power, we have 4 terms. A binomial raised to the 3rd power, we have 4 terms. To the 4th power, we have 5 terms, and so on and so forth. Now, Pascal's triangle is useful till the power 5, 6. Beyond that, it's not useful. You should determine these coefficients using n choose k. So again, this is like a puzzle. You just have to be careful how you multiply. How do you feel about this now? Is it better?
Yes.
So always remember the puzzle or the rule is power 4, you start with the first term, power 4, it decreases in the next term to power 3, to power 2, to power 1, and then it disappears on the last one. The second term is not in the first term. Power 1, power 2, power 3, and it's alone in the last term. This decreases from power 4 to nothing. This increases from nothing to power 4. Slowly but surely in each term. Always write it like this. Don't try to calculate before you expand it normally. And then simplify each term. Good. Any questions?